The Voters Project has developed a low-cost, vehicle-mounted system for assessing and mapping road deterioration. Here we are demonstrating the full Voters system in action. The map in the lower corner of your screen is constantly being updated with vehicle location and our sensor-based condition estimates, which are color-coded according to the legend. Watch here as the van hits severe deterioration at the end of this road. We expect the condition estimate to be very poor, either dark red or gray. And you can see by looking at the map that this is the case. Now as we continue driving, this section of road is much smoother, so we expect to get greens and yellows. And you can see that we do. Now I'd like to discuss the sensors that contribute to these condition estimates. Here's a figure showing our entire system. In a first round of processing, Voters algorithms are applied to data from each of these sensors to compute features of the road like surface texture, friction, profile, roughness, rutting, and crack density. A second round of processing then takes place where these features are combined in a data fusion algorithm. The final output is the condition estimates you saw at the beginning of this video. The most important contributors to the data fusion are the microphone, dynamic tire pressure sensor, and surface radar. Let's take a look at some of their raw data. First we have the microphone, a sensor we use to compute the road's surface texture, friction, and deterioration level. Here we see it in action. Corresponding raw data is shown in the top right corner. Spikes and high variation in the data are directly related to road damage. Watch here as spikes in the data sync up with a large pothole. Next we have the dynamic tire pressure sensor, a sensor we use to compute the road's profile and roughness. We use this sensor to compute deterioration level as well. Here we see action footage similar to what was shown for the microphone. I want to re-emphasize here that the data being shown is completely raw. No fancy algorithms have been applied. And this is something that we're proud of. We believe the data's immediate and obvious relation to road condition is why we're so successful when we later apply our processing. A third sensor is our surface radar. You'll see that spikes in the raw data here correspond to manholes or metallic road features, allowing us to perform asset collection tasks. This sensor can be used to detect other materials as well, and with further processing can even show the road's profile. Now to run these various sensors we require supporting systems. Here you see our 6 golf cart batteries for powering the system, and here you see our computer rack for data acquisition. This is our flip-down monitor for control and viewing sensor data in real time. An additional tablet display is mounted up front, allowing the front passenger to control and monitor the system as well. If you would like contact information, or if you have any questions about this video, or if you're just curious about the motivations for the Voters Project and how we stack up against the competition, then please view our project website.